Ionization energy. The periodic table provides information about the reactivity of elements. Potassium and copper are metals in the same period of the periodic table. Copper doesn't react with water, but potassium reacts rapidly and energetically. Cesium, which is in the same group as potassium, reacts even more explosively. Why do they react so differently? When a metal atom reacts with a non-metal atom, one or more of the metal atom's valence electrons is usually transferred to the non-metal atom. This can only happen if there is enough energy to overcome the attraction of the valence electrons to the nucleus. The amount of energy needed to remove an electron from an atom is its ionization energy. The attraction of an electron to the nucleus is counteracted by the repulsion of other electrons. Inner shell electrons shield the outermost electrons from the nuclear charge. In potassium atoms, all electrons except the single valence electron participate in shielding. This makes the effective nuclear charge relatively small. The effective nuclear charge of copper is greater than potassium, since copper's additional electrons are all in the outer shell and there is less shielding from the larger nucleus. Copper's outermost electrons experience a larger effective nuclear charge, resulting in a stronger attraction to the nucleus, a smaller atomic radius, and a higher ionization energy. Potassium and cesium are both alkali metals in group 1, but are in different periods. Both atoms have a single electron in the outer shell, with the remaining electrons effectively shielding the outer shell from the nucleus. These two atoms have similar effective nuclear charges, but the higher numbered shell in cesium is farther from the nucleus, so the electron is more weakly attracted to the nucleus and has a smaller ionization energy. Smaller atoms with electrons closer to the nucleus have higher ionization energies. So, ionization energy generally increases as you move up the periodic table, such as from cesium to potassium. Similarly, atoms with a higher effective nuclear charge have higher ionization energies. So, ionization energy generally increases as you move from left to right in the periodic table, such as from potassium to copper. Ionization energy reflects the attraction between the outermost electrons and the nucleus, and is useful for predicting reactivity. Key takeaways. To summarize, ionization energy is the energy needed to remove an electron from an atom. Smaller atoms that have electrons closer to the nucleus have higher ionization energies. Atoms with a higher effective nuclear charge have higher ionization energies.